Article 250.54 permits a supplemental grounding electrode to not be bonded to the grounding electrode system in accordance with 250.50. This exception is in place because the supplemental electrode is intended to act as a backup path to ground if the primary grounding electrode system experiences a failure. Now let's discuss the size of the Ufer ground. The size of the Ufer ground conductor has to adhere to the specifications laid out in 250.66b, which dictates a number 4 copper conductor for a 400 amp service. It is important to note that there are no contradictions between Articles 250.50, 250.53d2, and 250.54. Specifically, 250.50 mandates the bonding of all available grounding electrodes to create a unified grounding electrode system. Conversely, 250.53d2 allows for the grounding electrode conductor, abbreviated as GC, of a supplemental electrode to be bonded to the grounding electrode system. Then 250.54 offers an exception that permits a supplemental electrode to remain unbonded from the grounding electrode system. In the described scenario, the Ufer ground is treated as a supplemental electrode. Therefore, it isn't necessarily required to be bonded to the water pipe grounding electrode system. As for the other electrode types, steel, water pipe, rod, pipe, plate, and ring, these would all be deemed components of the grounding electrode system and would require bonding in accordance with 250.50. Despite the allowance for an unbonded supplemental electrode, it is generally considered a sound practice to bond all available grounding electrodes together. This approach leads to a more robust and reliable grounding system. Let's delve deeper into grounding electrode systems, focusing on 250.50 and associated sections of the National Electrical Code (NEC). Grounding electrode systems are designed to provide a low impedance path to earth, ensuring safety and proper operation of electrical equipment. The primary purpose of a grounding electrode system is to stabilize voltage to earth during normal operation and limit the voltage rise due to lightning, line surges, or unintentional contact with higher voltage lines. Section 250.50 of the NEC mandates that all available grounding electrodes, as described in 250.52a on through E8, must be bonded together to form a unified grounding electrode system. This requirement ensures that all electrodes act as a single, interconnected system, providing a more effective path to ground. The grounding electrodes specified in 250.52 include metal underground water pipes, metal and ground support structures, concrete encased electrodes, ground rings, rod and pipe electrodes, and other listed electrodes. Each of these electrodes, if available, must be connected to the grounding electrode system. Metal underground water pipe as a grounding electrode. A metal underground water pipe is often the primary grounding electrode, but it must be supplemented by an additional electrode type, as per 250.53d2. The water pipe must be in direct contact with the earth for at least 10 feet or more, including any metal well casing bonded to the piping system. The connection to the water pipe must be made within the first 5 feet from where the pipe enters the building. Concrete encased electrode. Ufer ground. A concrete encased electrode, often referred to as a Ufer ground, is a steel reinforcing bar or rod encased in at least 2 inches of concrete and located within the footing or foundation of a building or structure. The electrode must be at least 20 feet long. This type of electrode provides an excellent connection to earth due to the large surface area in contact with the concrete and the earth. Ground ring. A ground ring consists of a bare copper conductor, no smaller than number 2 American wire gauge, AUG, that is buried in the earth encircling the building or structure. The ground ring must be buried at a depth of at least 30 inches. Rod and pipe electrodes. Rod and pipe electrodes must be at least 8 feet in length and driven into the ground. The NEC specifies the types of materials and dimensions for these electrodes. For example, non-ferrous rods must be at least 5/8 inch in diameter, while steel or iron rods must be at least 1/2 inch in diameter. Other listed electrodes. The NEC also allows for the use of other listed electrodes that have been tested and found suitable for grounding purposes. These electrodes must meet specific requirements outlined in the listing. Bonding grounding electrodes together. To ensure all grounding electrodes function as a single system, they must be bonded together using a grounding electrode conductor, abbreviated as GC. The size of the GC is determined by 250.66, which is based on the size of the service entrance conductors. The GC must be securely connected to each grounding electrode using appropriate connectors or bonding methods. Supplemental grounding electrodes. As mentioned, a metal underground water pipe must be supplemented by an additional grounding electrode. This requirement ensures that the grounding system remains effective even if the water pipe is disconnected or becomes non-conductive. Common supplemental electrodes include concrete encased electrodes, ground rings, and rod or pipe electrodes. The supplemental electrode must be bonded to the grounding electrode system as per 250.53d2. Grounding electrode conductor size. In the size of the grounding electrode conductor is determined by 250.66. The table in this section provides the minimum size of the GEC based on the size of the service entrance conductors. For example, if the service entrance conductors are 4/0 AWG copper, the minimum size of the GEC is number 2 AWG copper. If the service entrance conductors are larger than those listed in the table, a calculation must be performed to determine the appropriate size of the GEC. Common grounding scenarios. Residential service grounding. In a typical residential service, the grounding electrode system often consists of a metal underground water pipe supplemented by a rod or pipe electrode. The water pipe is connected to the grounding electrode system within the first 5 feet of its entry into the building. The supplemental electrode is installed and bonded to the grounding electrode system. Commercial service grounding. Commercial services often utilize multiple grounding electrodes, including metal underground water pipes, concrete encased electrodes, and ground rings. All available electrodes must be bonded together to form a comprehensive grounding electrode system. Industrial service grounding. Industrial facilities may require even more robust grounding systems due to the presence of sensitive electronic equipment and heavy machinery. These systems often include multiple grounding electrodes, surge protection devices, and equipotential bonding to minimize voltage differences. Addressing common misconceptions. One common misconception is that a single grounding electrode is sufficient for all applications. However, the NEC mandates the bonding of all available electrodes to form a unified system. Another misconception is that the grounding electrode system is only for lightning protection. While it does provide some protection against lightning, its primary purpose is to stabilize voltage to earth and provide a low impedance path for fault current. Best practices for grounding electrode systems. Install all available grounding electrodes and bond them together in accordance with 250.50. Use appropriately sized grounding electrode conductors, as determined by 250.66. Ensure that all connections are secure and corrosion resistant. Periodically inspect and test the grounding electrode system to verify its effectiveness. Consult with a qualified electrical engineer or contractor to design and install complex grounding systems. Key takeaways. Grounding electrode systems are essential for electrical safety and proper equipment operation. The NEC requires the bonding of all available grounding electrodes to form a unified system. Proper sizing of grounding electrode conductors is critical for effective grounding. Regular inspection and maintenance are necessary to ensure the continued effectiveness of the grounding system. By adhering to these principles and practices, you can ensure the safety and reliability of electrical systems in residential, commercial, and industrial settings. Let's discuss 250.53d2 concerning supplemental grounding electrodes and how they interact with grounding electrode systems as outlined in the National Electrical Code, NEC. This section focuses on the requirement for supplemental electrodes when a metal underground water pipe is used as a grounding electrode. The metal underground water pipe is a common grounding electrode. Its effectiveness can vary due to factors such as pipe material, length of underground run, and the presence of non-conductive couplings or coatings. To ensure a reliable grounding system, the NEC requires that a metal underground water pipe be supplemented by an additional grounding electrode. Requirement for supplemental electrode. According to 250.53d2, If a metal underground water pipe is used as a grounding electrode, it must be supplemented by one additional electrode of a type specified in 250.52 at worth 38. This means that the supplemental electrode can be a concrete encased electrode, a ground ring, a rod electrode, a pipe electrode, a plate electrode, or another listed electrode. The purpose of this requirement is to provide redundancy in the grounding system. If the water pipe becomes ineffective due to corrosion, disconnection, or other factors, the supplemental electrode will continue to provide a path to ground. Acceptable supplemental electrodes: concrete encased electrode. Ufer ground. A concrete encased electrode, often called a Ufer ground, is a steel reinforcing bar or rod encased in concrete. It's an excellent supplemental electrode due to its large surface area in contact with the earth. Ground ring. A ground ring is a bare copper conductor encircling the building and buried directly in the earth. It provides a reliable grounding path and is often used in conjunction with other electrodes. Rod and pipe electrodes. Rod and pipe electrodes are driven into the ground and provide a direct connection to earth. They are a common and cost-effective choice for supplemental electrodes. Other listed electrodes. The NEC also allows for the use of other listed electrodes that have been tested and approved for grounding purposes. Bonding of supplemental electrode. The supplemental electrode must be bonded to the grounding electrode system. This is typically done by connecting the supplemental electrode to the grounding electrode conductor (GEC), which runs to the service equipment. The connection must be made using approved methods and materials, such as listed connectors and exothermic welds. The size of the GC to the supplemental electrode is determined by 250.66 based on the size of the service entrance conductors. Installation requirements. The supplemental electrode must be installed in accordance with the requirements of 250.52 and other applicable sections of the NEC. For example, rod and pipe electrodes must be at least 8 feet in length and driven into the ground to a depth of at least 8 feet unless rock bottom is encountered. The supplemental electrode must be located as close as practicable to the service equipment. This minimizes the length of the GEC and reduces impedance. Exceptions and special cases. There are some exceptions and special cases where the requirement for a supplemental electrode may be modified or waived. For example, if the metal underground water pipe is determined to be electrically discontinuous or is not available, the supplemental electrode may be used as the sole grounding electrode. In some cases, a combination of other electrodes may be used to meet the requirements of the NEC. Common scenarios and examples. Residential application. In a typical residential application, a metal underground water pipe is used as the primary grounding electrode, and a rod electrode is used as a supplemental electrode. The rod electrode is driven into the ground near the service equipment and bonded to the water pipe using a GEC. Commercial application. In a commercial building, a metal underground water pipe may be supplemented by a concrete encased electrode or a ground ring. The supplemental electrode is bonded to the water pipe and the building's grounding electrode system. Industrial application. In an industrial facility, multiple grounding electrodes may be used, including metal underground water pipes, concrete encased electrodes, and ground rings. All of these electrodes are bonded together to form a comprehensive grounding system. Addressing common misconceptions. One common misconception is that the supplemental electrode is only required for lightning protection. While it does provide some protection against lightning, its primary purpose is to ensure a reliable grounding system in case the water pipe becomes ineffective. Another misconception is that any type of metal object buried in the ground can serve as a supplemental electrode. The NEC specifies the types of electrodes that are acceptable for this purpose. Best practices for supplemental electrodes. Choose the appropriate type of supplemental electrode based on site conditions and the requirements of the NEC. Install the supplemental electrode in accordance with the manufacturer's instructions and the NEC. Use approved methods and materials for bonding the supplemental electrode to the grounding electrode system. Periodically inspect and test the grounding system to verify its effectiveness. Key takeaways. When a metal underground water pipe is used as a grounding electrode, the NEC requires a supplemental electrode. The supplemental electrode must be of a type specified in 250.52 at worth through 8. The supplemental electrode must be bonded to the grounding electrode system. Proper installation and maintenance of the supplemental electrode are essential for electrical safety and reliability. By following these guidelines and best practices, you can ensure that your grounding system complies with the NEC and provides effective protection against electrical hazards. Now let's look more closely at 250.54, addressing supplemental grounding electrodes and their bonding requirements within the framework of the National Electrical Code (NEC). This section specifically deals with the situation where a supplemental grounding electrode is installed but not necessarily bonded to the main grounding electrode system. This is a departure from the general rule that all available grounding electrodes should be bonded together, as stated in 250.50. Purpose of 250.54 Section 250.54 allows for supplemental grounding electrode to be installed without being bonded to the main grounding electrode system. The primary reason for this provision is to address concerns related to impedance and circulating currents in certain situations. By not bonding the supplemental electrode, the impedance of the grounding path is increased, which can help to reduce or eliminate unwanted circulating currents. Conditions for applying 250.54 Section 250.54 is typically applied in situations where sensitive electronic equipment is present and the reduction of noise and circulating currents is critical for proper equipment operation. For example, in a data center or telecommunications facility, it may be desirable to install supplemental grounding electrodes for specific equipment without bonding them to the main grounding electrode system. This can help to isolate the equipment from noise and interference that could be present on the main grounding system. Requirements and restrictions when applying 250.54. There are several requirements and restrictions that must be followed to ensure safety and compliance with the NEC. The supplemental grounding electrode must still meet the requirements of 250.52. This means that it must be of a type specified in 250.52 at or through E8, such as a concrete encased electrode, a ground ring, or a rod or pipe electrode. The supplemental grounding electrode must be installed in accordance with the requirements of 250.53 and other applicable sections of the NEC. The equipment grounding conductor, abbreviated as EGC, for the equipment served by the supplemental grounding electrode must still be connected to the main grounding electrode system. This ensures that there is a low impedance path for fault current in case of a ground fault. The supplemental grounding electrode must be clearly identified and labeled as such. This helps to prevent confusion and ensures that it is not inadvertently bonded to the main grounding electrode system. Benefits of applying 250.54 reduction of noise and circulating currents by not bonding the supplemental grounding electrode to the main grounding electrode system. The impedance of the grounding path is increased. This can help to reduce or eliminate unwanted noise and circulating currents that could interfere with the operation of sensitive electronic equipment. Improved equipment performance by reducing noise and circulating currents. The performance of sensitive electronic equipment can be improved. This can lead to more reliable and accurate operation, as well as a reduction in downtime and maintenance costs. Increased system flexibility. Section 250.54 provides increased flexibility in the design and installation of grounding systems. It allows for the customization of grounding systems to meet the specific needs of different types of equipment and facilities. Drawbacks and considerations. While 250.54 can provide benefits in certain situations, there are also some drawbacks and considerations that must be taken into account. Increased impedance. By not bonding the supplemental grounding electrode to the main grounding electrode system, the impedance of the grounding path is increased. This could potentially reduce the effectiveness of the grounding system in case of a ground fault. Potential for voltage differences. If the supplemental grounding electrode is not properly installed or maintained, there could be a potential for voltage differences between the equipment served by the supplemental electrode and other equipment connected to the main grounding electrode system. This could create a shock hazard. Complexity and confusion. The application of 250.54 can add complexity to the design and installation of grounding systems. It is important to ensure that all personnel involved in the installation and maintenance of the system are properly trained and understand the requirements of the NEC. Common scenarios and examples: data centers. In data centers, it is common to install supplemental grounding electrodes for sensitive electronic equipment without bonding them to the main grounding electrode system. This helps to reduce noise and circulating currents that could interfere with the operation of the equipment. Telecommunications facilities. In telecommunications facilities, supplemental grounding electrodes may be used for specific equipment to isolate it from noise and interference. Industrial facilities. In industrial facilities, supplemental grounding electrodes may be used for equipment that is particularly sensitive to noise or that could generate high levels of noise. Addressing common misconceptions. One common misconception is that 250.54 allows for the complete isolation of equipment from the grounding system. However, the equipment grounding conductor must still be connected to the main grounding electrode system. Another misconception is that 250.54 can be applied in any situation where a supplemental grounding electrode is installed. However, it is important to carefully consider the potential drawbacks and to ensure that the requirements of the NEC are followed. Best practices for applying 250.54: carefully evaluate the potential benefits and drawbacks before applying 250.54. Ensure that the supplemental grounding electrode meets the requirements of 250.52 and is installed in accordance with the NEC. Connect the equipment grounding conductor for the equipment served by the supplemental grounding electrode to the main grounding electrode system. Clearly identify and label the supplemental grounding electrode. Provide training to all personnel involved in the installation and maintenance of the grounding system. Key takeaways. Section 250.54 allows for a supplemental grounding electrode to be installed without being bonded to the main grounding electrode system. This provision is typically applied in situations where sensitive electronic equipment is present and the reduction of noise and circulating currents is critical. When applying 250.54, it is important to carefully consider the potential benefits and drawbacks and to ensure that the requirements of the NEC are followed. By following these guidelines and best practices, you can ensure that your grounding system complies with the NEC and provides effective protection against electrical hazards.